Hello, everyone, and thanks for being here. My name is Rob. I'm a senior software engineer with the New York Times, and well, we can start right now. Okay, so this talk will be a journey that an Android dev could make in order to start using Kotlin multi-platform. So this talk is by no means an introduction to the platform. Our friends at TouchLab can do that much better than I would do. It's more like an opinionated path that I followed to create my very first app that not only runs on Android, but it also runs natively on iOS. So let's get started. Before we dive in, there are a few things that actually I want to mention and set as premises. The first thing is that, well, we are all here because we definitely, well, are Android developers. Personally, I don't want to be a cross-platform developer. I prefer much more to stay on Android and only occasionally work on something else. But my main goal is by any means Android. And I want to use as much of my knowledge as possible. That means that everything I learned to use in the past years that I've been working on Android, I want to apply to this new experience. So of course, we have to rely on Kotlin. But there are other languages that we could use to create something that could run on both Android and iOS. So if we were, as of today, to build an app that would run on both the platforms, we could rely, of course, on Kotlin for the business logic, and we could actually build our UI with Dart and Flutter. Personally, I think that I would have loved Dart way more if it came out for mobile before Kotlin was a thing. But now I feel that Dart is a bit too close to Java for my likings. So probably I would instead decide to keep on being on Kotlin for everything Android and add some Swift to the mix so that we can draw something nice on iOS as well. So for everyone that don't know me, I'm a huge fan of the Empire State Building. Every time I'm in New York and I happen to be around, well, I always stop by and just look at the lights. But since I love taking pictures, it never occurred to me that actually I could know in advance what would be the color of the lights per given night at the Empire State Building. Luckily, there is a website that helps us in, that actually is a calendar and can tell us the different lights and the motivations behind these lights. But there are a couple of issues. So the first one is that, well, this website doesn't really provide an API. So we had to find a way around it by using Ktor and basically scraping the data so that our app could use it. And well, I decided to use Compose and Swift UI to build the part of the UI that differs on Android and on iOS. So our project will mainly be a simple app that will make a network request to a backend and it will show some data, hopefully with loading and error states. And in my feeling, well, this is most of the things that usually app do. Of course, there are many UI things to take care, but the core is something close to this one, probably much more complicated, but still close to that. So let's dive in the usual architecture that we give to such an app on Android. Of course, the first step is an activity or a fragment. Well, basically, you will have an activity at some point. Then we have probably a view model. At least as of now, my advice will always be to use a view model since we are on Android, and that would help us quite a lot with network requests. And this, of course, comes from Jetpack. The next step, it's very important, and it's something that will make our network requests cache in case we need and return our data. And then, of course, there is a backend because, well, we need some data to be coming from somewhere. Out of all of these, what we can really share is the repository. Well, this should ideally be something that doesn't depend on the platform, but it's not always the case. Especially people that are not as new on Android, they will probably always go to retrofit JSON and Moshi when it comes to network requests. Unfortunately, since we are doing, well, our goal is to use the same code to run on both Android and iOS, well, we cannot really use those because those are Java libraries that don't yet run on Kotlin native. So we have to rely on something else that can actually run on multiple backends, which are Ktor and Kotlin X serialization. Those two libraries are quite different from what we are used to on Android, but they're not that complicated. And once we replace retrofit, JSON, or Moshi with Ktor and Kotlin X serialization, well, our repository now is really not depending on Android at all. So what does that leave us at? Well, basically, we now have a clear understanding of what is everything related to Android, which is basically everything that is the view layer and the view model. Why I chose to include the view model on Android? Well, because I usually use the view model from Jetpack, and I use live data to expose my data. And I kind of think that on iOS we can have something very similar, and we can make our repository much, much easier to understand and to code without worrying about all the view model layer. And even if we write twice, it's not really that big of a deal. At this point, we know for sure that the repository is something that we can share, and this is something that we want to share. We don't need to change anything for it to work on Android, apart from changing our libraries. So it's a really minimal sacrifice, in my opinion. And of course, well, ça va sans dire, the French would say, well, this has to be written in Kotlin, of course. So let's start with the code that is on Android, but not only on Android. So the first thing that we want to do is using Android Studio, because, well, the vast majority of developers are used to Android Studio, and that's the IDE that I'm more familiar with. Okay, it is IntelliJ or Android Studio, it doesn't change that much because the same would apply to both. But it's important that we stay on Android Studio as much as possible because we probably know Android Studio way better. We are way more familiar with Android Studio than we are with any other IDE. And well, I for sure prefer Android Studio over Xcode. Call it preference, call it muscle memory. I just prefer Android Studio. So I want to stay as much as possible on Android Studio. But when I started preparing this talk a few months ago, well, we had to create every folder by hand. And that's why the friends at TouchLab created this amazing project. If I remember correctly, it's called Campfire, which will basically kickstart your project and give you all the dependencies already set. Well, now, while this project is still valuable, there is something else that we can use, which is the Kotlin Multiplatform mobile plugin from JetBrains. So this is freely available on Android Studio, and once installed, basically, well, it's done. We don't need to do anything else. So we just need to install this plugin, start our IDE, and then we can simply create a new project. When we create a new project, we have to go all the way down to the last item in the list and select a KMM application, which is a Kotlin mobile multi-platform application. At this point, we follow up with the instruction, sorry, and we end up in the final panel where we can configure the names of our modules. As you can see, here are already filled with Android app, iOS app, and shared. Here, I didn't check the add sample tests for shared module because, well, I was only doing network request and I didn't really need to run tests on that. So once we click on finish, Gradle will start doing its magic and everything will be created for us. And then we can start writing some code. But well, we should not be that impatient to write some code because we need Gradle to fully complete before we can start leveraging everything from the Kotlin mobile multi-platform. Something that happened to me is that, well, I started opening files to wander around, and then I found this nice error. Basically, this error is because, well, not everything was being created and synchronized by Gradle, so it was telling me that basically couldn't find something in the iOS main module. And if it's the first time that you use Kotlin mobile multi-platform, this might sound scary, but you just need to leave Gradle do its magic and it will work flawlessly. Okay, now we told that we wanted our repository to be shared, but it's not the only thing. Well, we also want our modules to be the same, models, sorry. We don't want to write the models multiple times, and definitely we don't want to leverage that much of the platform native data as long as possible. So we have two main models for this request. The first one, the daylight, represents the lights that will be used for color the Empire State Building in the future. So we have the image URL because we want to show the picture of the Empire State Building to give a sense of what the light could be. The color, which is a string. Unfortunately, I couldn't parse the color properly because, well, the data script was literally orange rather than sky blue or a combination of colors. So it wasn't really easy to translate that to an X value or a list of X value. Then we have a reason because every light is dedicated to something. For instance, on Columbus Day, the lights are usually green, white, and red, if I remember correctly. And then we have the date in which these lights will be light on. So the date is a string because when I started this project, there wasn't a, a better, well, probably there was, and I wasn't aware, but I wanted to use the Kotlin take time. They weren't ready yet, so I didn't format the data, and I kept the string. Of course, in a real project, I would advise not to use a string for data. That will be much more complicated. But we just want to display data that comes in different formats based on the language from the website. So for the moment, yeah, it's fine. The second class is what the response actually the server returns to us, and it contains the color that is used tonight, the URL of the picture, and the list of the next lights. Okay, probably you already know that, but well, we needed to add a net serializable annotation so that the JSON serializer could understand what class and adapters it needed to create in order to deserialize our response. It's important to know that even if we, when we annotate a class, all the child and all the class contained in that class have to be annotated in the same way. Otherwise, the Kotlin compiler will complain because from a given point, all the hierarchy depending on that class should be serializable for that class to be serializable as well. And this comes from the Kotlin serialization library. Of course, this goes in the shared folder. So what we created now is basically the model that will be represented in our UI. Now, let's go a step further and let's check our repository. Of course, this repository is pretty simple. What we do is creating an HTTP client, which comes from Ktor, install the JSON functionality, instruct our JSON object to ignore the unknown keys in case there are, and then we assign the Kotlin serializer that comes from Kotlin serialization to our HTTP client. Now, differently from retrofit, we don't create an interface where we list all our calls, but we rather use the HTTP client to invoke a method that corresponds to the type of call that we want. So in this case, we invoke the get method giving an endpoint, and we specify the return type that we want our service to return. Is it harder than retrofit? Probably not much. It's different. So if you're used to retrofit, it might be confusing at first, and it would somehow look unnatural, at least to me it did. But, well, after a while, I think that it actually got into me and I came to like Ktor as well. Okay, of course, we didn't need any caching. Otherwise, we could have added the cache using SQL Delight or something that runs on Kotlin Multiplatform. Then we switch to Android and we create a view model. So what changes from Android standpoint? Well, not much actually. Well, if we take a look to our view model, well, the first thing that we notice is, well, that there is nothing new from what we would do with any other repository coded just for Android. Of course, we didn't use dependency injection in this project, but in case you need dependency injection, you can use Coin. It should work. If I remember correctly, it works on Kotlin Multiplatform, but well, here it was not needed. We just had one dependency. So it was more the overhead than anything else. Then let's dive into the load lights function, which is very, very interesting. So for this sample, in order to give the app the possibility of showing the loading, the completion, and the error, the success, sorry, and the error state, I used a pattern called LC, stands for loading complete error. Basically, is a select class with 3 or more, based on your implementation, states that are, of course, the loading, which always comes first, the completion, and the error. This paradigm is very nice because it always gives us a flow which only goes in one way. So we always start from the loading, we end up in either the completion or the error, and if we want, we simply restart the loading and again and again and again. And this is actually what we do here. Basically, we use immutable live data to post a value. It's not needed here because we are already in the main thread. So a normal live data with a set value would have worked the same way. So it's just the force of habit, I believe. Then we use the view model scope to launch our coroutine. We get the result from the suspending function that we just declared in the repository. And in case something goes wrong, well, we just set the error. And basically, that's it. So for Android, nothing really changed, apart again from Ktor and probably Kotlin serialization. Of course, well, not everything goes always as smoothly as it could go. So the first error that I encountered was this unsupported modules detected. Honestly, I didn't understand why this would happen. Then wandering around the web, well, I found that probably it was just something weird inside Android Studio. And the solution is basically to close your IDE, delete the .idea directory and all the .iml files in the project. Then you import the project and hopefully it should fix it. To be honest, this only happened to me 3 or 4 times top. And I solve it every time in this way. Hopefully it doesn't happen that often. So hopefully, let's cross our fingers. But the next one is actually much more interesting. So as we mentioned in the beginning, I decided to use Compose in order to render our UI. Well, of course, Compose only runs on Android Studio Canary as of today. So it happened that one day I was on Canary 14 and everything was working fine. Then I used JetBrains Toolbox with out of date enabled. I'm that crazy. And Canary 15 came out. I reopened the project and I was presented with this error. Honestly, it was scary. It was like, I don't even understand this error. What is all about? So I wandered on the network, and basically it was because I was using an older version of Gradle. So basically I was using a milestone version of 6.7, and well, basically it turns out that upgrading to 6.7 stable or 6.8 would fix the issue. And this actually was a known issue on the JetBrains UTrack, and you can find it with that code. Okay, now let's switch to iOS, which is the part that I was both expecting and fearing at the same time. So luckily, there is now a very nice sample and code lab from JetBrains developer advocates that basically covers everything that I learned, and also the caching with SQLite. So if you are interested in Kotlin multi-platform for mobile, well, this is the code lab that you should be checking. One important thing to mention is that you should follow all the dependencies versions that are pointed out in this code lab. Because if you follow up the specific version up to the betas and milestones, there are good chances that actually everything will work as expected. Otherwise, if you update something else, like in my case, I updated Android Studio, chances are that you're presented with some errors. So be aware of that. Everything can be solved. But still, it makes sense to follow the dependencies when possible. So, well, if you're like me, well, you're all curious about how to use coroutines on iOS. Well, it's doable, probably just not as I hoped they could be used. So that was a Swift rookie mistake, and I know now. I expected it to use the extension function to be usable in some ways to Swift. Of course, they cannot be used as we expect them to use on as we are used to use them on Android. But well, there is another way to use coroutines. So, okay, this may look like a lot of code, but well, bear with me for a moment. So the first thing that you want to do is extend the content view, which is basically what will render our UI. We create inside this extension an enum which is really like the LC pattern that we saw on Android. Basically, we have the loading state, the result state, and the error state. And then we create a view model, which is an observable object. And it will work mostly like it works on Android. As a dependency, we pass our light repository, which is declared in the Kotlin Multiplatform module. And then we invoke this function, which is not suspending, and it's called load lights. I mentioned that it's not suspending because it's inside here where we're going to use the coroutine. So we have our repo, and we invoke the get lights function by passing in a completion handler, more or less like we would do with Java. This completion handler takes in two parameters in its lambda, which are the lights and the error. And well, it works exactly like an Android. So in case everything goes smoothly, we invoke the result and we pass in the lights. If there is an error, well, we invoke the error state. It's important to notice that here as well, we start with the loading state so that we have loading, complete, and error once again. Now, what we do is basically listen to the viewModel.lights field, and based on what you get, well, we create a different UI. I won't show you how I created the lights view because it's out of scope and we are almost out of time. But well, the result of this mix was this one. Of course, not the prettiest UI ever, but it gives you, well, it makes you feel better when you can create something like that on two platforms, one of which you basically never used in your entire life. And with that, I think I'm done. You can find me on Twitter at _twids. Slides will be available later today. And now it's time for questions, if you have any. Oh, thanks. Okay, so we can wait a few more minutes if we have any further question. Thanks again to our anonymous user. And Well, I think that we don't have any other question. So thanks all for joining me tonight, I guess. Well, here is night. And have a good night, everyone. And thanks again for being here. How would you add platform-specific APIs? So in order to do so, you would leverage the expect actual implementation. So basically, you would create an interface which is an expect interface or an expect function based on what you want to do. And then you will need to create an actual implementation on your Android and iOS folder and return the same, well, basically they will need to return the same data. So you will need to wrap anything that you have coming from the platform. One example of these might be probably location. If you need at, well, at, let's say lower level in architecture, not lower, but I mean, in at the repository level or lower. So playing with expect and actual, you could make it work. One example on how to do that is as soon as you create the project, it will create a function that will tell you the platform, and it's an expect function on the shared code, and it's an actual implementation on both Android and iOS. Okay. Any other question? Okay. Probably not. Okay. Thanks again, everyone, for being here. It was amazing being host at the guest, sorry, at droidCon Americans. So good night, everyone, and thanks for being here.